Hi, my name is Chloe Wheeler. I'm going to be doing my project, my capstone project over body fat and heart disease. I did want to make one note. My main computer camera is not working. I can't figure out how to get it on, so I'm having to use my work laptop. So I will be looking over here at this other desktop that I have so that I can reference the data. So first, I'm going to start out with body fat. I've already ran this, so I won't run it again because they're already deleted. But this right here, this negative sign in front of the C, basically is there to remove all of these columns that I have listed. I felt like those variables weren't super necessary. And so these ones that I have right down here are the ones that I think impact body fat the most. And so then next, we're going to build the linear regression. So LM stands for linear models. So we're going to go ahead and run that. So the variables that I did think that were the most important were density, age, weight, height, chest, and abdomen. And then we're going to run this prediction. So this is used to compute the predicted probabilities. And then the next one, this is used to convert possibilities or probabilities into binary, so 1 or 0, and then also using a cutoff of 0.5. Okay. And then, okay. So one thing I wanted to point out here was the standard error at the intercept is 9.4, so that is a little high to me. And then the maximum is 15.5, and the minimum is a negative 0.3. So kind of a wide range there. Okay. And then the next thing that I wanted to point out from these is that these two both are matching pretty much. So that one right there is 12.3, and then down here it's 12.2. So that looks pretty good to me. 6.1 and 6.1, 24.4 and 25.3. So that looks really good to me. Yeah. Okay, so next we're going to do the decision tree model, a regression one. This first thing, it is just trying to get rid of any missing values. So I've already done that, and it looks like there aren't any, so that's good, but always want to make sure that we do that. And then our training data, which is what we use to build the model, is I'm using these values 1 through 50, 100 through 150. These were kind of just random. I just picked some, and then the evaluation data. So this is what evaluates the data. It's what does all the testing and everything. So next, we're going to build the model. So our part is used to create decision models. So that's very important in this decision tree. So we're going to run it. And there's those variables again. And one thing I wanted to note is that we use this type of method because this is a regression decision tree. And then we use this vector type because, again, this is a regression decision tree. Okay. So on these numbers are a little bit further off from each other. So you see that one's 10.2, and then one is 11.7, basically. 6.6, 6.1. That's closer, but it's not as close as the linear model was. So then we're going to run this. So the MAE, which stands for mean absolute error, is 1.48. In this example, I think either model was fine, but I do think that the decision tree had a better standard error amount that was like significantly less at the intercept. So now that we have compared those, we're going to move on to heart disease. Okay, so we have to download that. And then this is kind of the very first thing that you want to do is do all the cleanup entries or lines of codes. So all of these were not factors, so we want to make sure that we get those fixed. So now we want them to be categorical variables. Okay, so then I picked out, like I said on the last one, I kind of picked out just random, um, these are not for any reason. I picked them. I liked the numbers. Um, so again, the this is the data that we use during testing. Okay, so now we're going to build the model. So GLM actually stands for generalized linear models. So that's what it does. It just performs those. And we're going to go ahead and run it. So we're using Model 3 to make predictions on the evaluation data. We use R to compute sensitivity and specificity. Um, I can't really say that word, so I'm sorry. And then we're gonna do the prediction curve, and then we're gonna do the prediction binary. So again, we're seeing that if else, and we're seeing the 0.5 cutoff, and then the 1 and 0. Binary values are to identify true positives when the target class is correctly predicted, as well as true negatives when the non-target class was predicted. So these two, this 2, 2, 1, and 3, 2, 2, those were correctly predicted. This 48 is a false positive, and this 44 is a false negative. And like I said right there. So our accuracy rate right now is 85.5. So that's pretty good. That's not bad at all. Okay, so we got that. And next we're going to do the decision tree. So again, we're going to make sure that there's no NAs or missing values, which there's not. So that's great. And then again, I picked out just random ones throughout the data for my training and evaluation data. So first we're going to build the model. We use our part to create the decision tree model. Since the target variable heart disease is categorical, the method will be class. So again, we're using that R part. So see how the difference is both of these are class, and that's because it's categorical. Okay, so here we go. So these are the ones that were predicted correct, so that's pretty good. Let's see what those other ones were. 2, 2, 1, and okay. So looks like we were a little bit higher on this one, but a little bit lower on that one. So, I mean, relatively close to each other. That's great. Yeah. Okay. Okay, so I did want to talk a little bit about the specificity. It shows the probability that there is no heart disease. And so the sensitivity is the opposite. It shows when um there is a probability of heart disease. So it's showing that there's 84% sensitivity and then 84.5, or I guess you could round that up to 85. So that's pretty high for the um specificity. But we're not too worried about this one. And then our accuracy percentage was 84.5. So let's see how that varies. So it's a little bit lower than our other one. Um, yeah. So overall, I think the logistic regression was better for that one in the long run because it was more accurate, and the data looks great. So I think that is all that I have. Thank you so much.